We now learn about the different types of data that we'll need to know about when studying statistics. Now, there are two main types of data. Those are qualitative data, that's qualitative, and quantitative data. Let's start with qualitative data. Data is said to be qualitative if its values are described by their quality or their belonging to a certain type or category. Put simply, data is qualitative if its values are not numbers. For example, if we were to write down the number of occurrences of the different eye colors that we can see in our school, then the data we would collect would be qualitative data, since each value of data would be a color, like blue, green, brown, and so on. Another example could be if we were to ask 100 people what their favorite sport is. We'd end up with a large list of qualitative data. Each value of data would be a name, like football, swimming, tennis, and so on. Now, to analyze and interpret qualitative data, we usually use graphical methods, things like bar charts or pie charts. And the purpose of that type of graphical method is to highlight which data values are the most frequent or the least frequent. And we'll soon learn how to do each of these. So all in all, qualitative data is non-numerical data, which we'll usually analyze using graphical methods. On the other hand, data is called quantitative if its values are numbers. For example, if we were to measure the heights of all the students in school, then the data we would collect would be quantitative data, since each value of data would be a height measured in meters, centimeters, millimeters, or feet, or any other unit of length. Another example could be, say we were to look into all the different selling prices of the best-selling phones in various countries around the world. Then the data we would collect would again be quantitative data, since each value of data would be a price, which is, of course, a number. Now, to analyze and interpret quantitative data, we'll still have graphical methods, including the ones we have for qualitative data, but we'll also have numerical methods and measures that will allow us to interpret and understand the data we collected even further. And a very quick example could be, let's say we have 4 grades obtained by students at a math test, and let's say the grades are 4, 6, 9, and 7. These 4 grades are data, and they're quantitative data. And there are several things that we'll be able to do with these 4 grades. For instance, we could calculate the mean, which is commonly called the average. And if we were to do so, we would find that the mean is equal to 6.5. So, assuming that this test was out of 10, these 4 students had a mean score of 6.5, which gives us an idea of how well the students did as a group. Now, that's just an example. There are many more numerical measures that we'll be learning about. So, of course, we have the mean, but we also have the median, the mode, the range, and even the standard deviation. And all of those things will help us better interpret and understand the data that we've collected. And we'll learn how to do this for data which has far more values than just these 4 grades that we have here. Now, don't worry if you don't know some of these terms like median, mode, range, or standard deviation. We'll soon be learning what each of those means as well as how to calculate them. For now, though, it's important to realize that the type of analysis that we'll do with quantitative data is somewhat different to what we can do with qualitative data. And on top of all this, there's something more to be said about quantitative data. Any quantitative data falls in one of 2 subcategories. It will either be discrete data, or it will be continuous data. And in fact, we'll now spend a bit of time working on understanding what is meant by discrete quantitative data and continuous quantitative data. Put simply, discrete data is data that can only take on certain values. Often, all the possible values can be written in a list, meaning they are countable. Some typical examples would be things like shoe sizes. Let's say we were to ask all of our students who are older than 10 years old to write down their shoe size on a sheet of paper. And we would then collect all those shoe sizes. Well, depending on the size of the school, we would be collecting quite a large amount of data. But each and every single one of those values would be one of the following values: 4, 4.5, 5, 5.5, and so on, all the various shoe sizes, all the way up to, say, 14, 14.5, and 15, assuming we can stop there. Now, what this highlights is the fact that all the shoe sizes that we may have in the entire school will be one of these numbers, and there can't be any others. For example, we won't find someone with a shoe size of 7.396, since that shoe size doesn't exist in stores. Shoe sizes can only take on certain values, and that's characteristic of discrete data. Another example could be the number of cars that a company sells in a day. One way of understanding that that's discrete data is to realize that we can't sell, for instance, 20.27 cars. No, the number of cars we sell has to be a whole number, which shows us that the number of cars sold can only take on certain values, and those values are the whole numbers. Continuous data, on the other hand, is data that can take on any value within a certain interval. And it's not possible to write down all the possible values that continuous data can take, since the list would be infinite. Two typical examples of continuous data are length and time. For example, if a group of 100 students were to time themselves whilst running around the school, then all the data collected could and would be any number between the fastest and slowest times recorded. And this can be illustrated on a portion of the number line. Let's say the fastest time was 1 minute 30 seconds, and say the slowest time was 3 minutes. Then all the data that we'll have collected for the other 98 students could be any number on this portion of the number line. And let me just highlight that. All the other values of data could be absolutely any of these numbers that I'm highlighting in red right now. And that is what makes this data continuous, the fact that the data can be any number on a portion of the number line. And in fact, all continuous data can be illustrated in this way, with a number line between two values, say A and B, and all the values between A and B. For the sake of comparison, discrete data on a number line between A and B would only be represented by certain points on this number line, whereas continuous data can take on any value between A and B. And there we have it. Those are the different types of data we need to know about when studying statistics. In summary, there are two main categories of data: qualitative data and quantitative data. Qualitative data corresponds to any data that is non-numerical. That's things like colors, names, or brands. Quantitative data corresponds to data whose values are described by a meaningful number. Things like time, length, or price. And remember, quantitative data falls into one of two subcategories, either discrete data or continuous data. And each of those was defined just a couple of minutes ago. And that's it for this tutorial. There we go, everyone. I really hope that helped, and if it did, please hit like on this video and even subscribe to our channel, because that really does help us. I'll see you soon.